moderate our session today. We're going to get right into NeRFs and photogrammetry and really dig into this. And then if there's time, we'll do some Q&A. A nice friendly faces over there. Hi, Alex. All right. All right. Thanks, everybody. Let's have a hand for our panelists.
I didn't realize that we were all gothed out, so good. So my name's Lasky. I have a kind of deep background in LiDAR and photogrammetry, and I worked at volumetric at a company like 8i and things like that. I used to do LiDAR scanning for the movie industry. And just to kind of kick things off, I brought a prop from the Alan Lasky Dead Technology Boneyard. Anybody recognize what that is? Okay, so this is the Litro light field camera, okay, from back in the day. And I thought that this would sort of be a good example of sort of the promise and the peril that's involved in this industry. It can be kind of a perilous thing to do, but I just wanted to bring that up. But before we really dive into it, I just wanted to have all the panelists introduce themselves. So why don't we start here and go down the list?
I'm Andy Cochrane. I'm a kind of creative technologist working in media and entertainment, and that's everything. XR. I was Madison Square Gardens for 3 years building the Sphere. Just anything that's kind of high tech and creative combining that's my jam. So NeRFs are one of my current jams.
I'm Alexx Henry. I'm CEO of BlueVishnu, and we have the 3D scanner that's in the other room. You guys should all go check it out. It uses photogrammetry to rapidly produce a model and send it to you.
My name is James Perlman. I'm a software engineer with a relentless fascination with NeRFs.
I'm Jason Schugardt. I'm solutions architect for NVIDIA. I cover the media and entertainment space, chasing all the cool tech and getting to the smart people and getting the answers for you. Backgrounds in visual effects, so spending lots of time on set, commercials, features as a visual effects supervisor in the industry.
Cool. So I'm wondering, we're going to start by the sort of, bell of the ball here is NeRFs. So we're going to start by talking about NeRFs and probably talk a lot about them. So I'm wondering, do we need to get down off the stage or at least sit lower to see the videos so that the audience can see them?
That's a bigger set direction question that should have been taken care of a day ago.
Look, we've already been yelled at. Perfect. Perfect.
I mean, you can absolutely do whatever you're comfortable with.
Okay. I mean, would it make sense for us to just jump off? Or?
We haven't been doing that, but you're welcome to.
I think it's fine in the background. Yeah,
cool.
Yeah.
So we're going to start with Jason, and we're going to actually, or are you going to? Oh, you're going to start, but he's going to drive the. So I'll let you.
We're going to wing it there.
Okay.
Yeah.
I'll let you guys sort of introduce NeRFs and the concept of NeRFs because this is kind of the new hot thing.
Right on. So I'm going to skip over how to capture them and create them. I'm just going to kind of describe what they are. So what is a NeRF? It stands for neural radiance field. And unlike traditional photogrammetry where your scene is represented by like a triangle mesh, NeRFs are a continuous multidimensional volumetric representation. Now, what does that mean? So if you think of it like a cloud or like a box of colorful fog, in a NeRF model, the neural network is used to shape this fog into something that is spatially consistent and looks good to human eyes. So let's check out one right here. So this is a NeRF training. And we give the network two things. We give it the camera poses, which have which is like the focal length and where it is in 3D space. And we give the network the ground truth images. And what it does, and we tell the network, you can change two basic things about this cloud. You can change the density and you can change the color of it at any point that you want. And the constraint is that from the perspectives of the input images, this cloud must look as identical as possible. And the network's like, I got you, bro, check this out. So after many iterations, you start to see an image resolve, and it is indeed one that is spatially consistent. So sometimes we can get pretty spectacular results. This was rendered in NVIDIA's Instant NGP and adding a little bit of background blur for effects for zhuzh, exactly.
It's all ray traced. So the scene is just looking at the whatever field of view you set and aperture, and you can ray trace those effects right into the camera, so it is accurate.
Yeah, and it's fast. That was a brilliant thing from Incident GP. Okay, so one of the great benefits is the view-dependent effects, like subtle color changes and specular reflections. And this kind of stuff gets us really much closer to photorealistic synthetic 3D. This one was rendered with MIP NeRF 360, and you can kind of see, like on the bottom, oh, I don't know if you can see the actual bottom, but it's quite reflective, that table.
I think some of the power of NeRFs come from photogrammetry. Photogrammetry will bake in highlights, cook it into the texture. You'll get you may get a reflection, but it's going to be static based on the geometry where it is. Where I think the strength of NeRFs, it is view dependent, and it is highlights will change, reflections will change. This means that objects that are reflective still feel photographic, and things like hair that are or objects that are translucent are represented correctly as well. So photogrammetry will not do a clear vase really nicely, where NeRFs will represent that very well. You can see the on the back right at the very end coming around, you'll see a glass structure. As a photogrammetry object, that glass would not have appeared correctly.
Yeah, absolutely. Lots of fun materials in here. And so you can see kind of like what this is doing. This one shows a little bit more about reflections. So if you don't know, this is Karen X. Chang. She is a brilliant director, artist, influencer, musician, etc. And so this window, or this mirror here, is actually treated as a window. And we did some clever things to sort of fill in the background detail, because you can't normally see like behind an object. But essentially there's not like reflective surfaces, so it's inventing scene geometry beyond the mirror. And so you can kind of see like how that works. Reflections aren't really reflections, they're just like deeper scene geometry, but it's fun.
Can I give away the gag in this?
Yeah, please go ahead.
So the part that I think is genius here, and it may not be obvious, is how do you see into another room? Well, they just scanned one side of the room and then mirrored the camera data, so you can now, you may have gotten a little bit of into the other room, but now because they've mirrored the camera data into the JSON file and then trained on the duplicated cameras that are mirrored, you're now able to travel between the two rooms with way more data than you would have gotten with just to capture into a mirror. So really, really clever in this. And this trick plays out again in another slide coming up here.
Well, before that, what's better than one NeRF? Obviously, it's 4 NeRFs. And this is just an example of doing multi-scene compositing and a little bit of storytelling. This is Michael from Frank-Lucent, who is a legend in the NeRF space. And if you see him, he is somewhere in this audience. And if you stand completely still, he might just take a NeRF of you. So do with that information what you will. This is a fun one. Nobody was hurt. It's just a NeRF, bro. This was 2 separate NeRFs 3D composited into each other. So yeah, watch out for Michael. So how do you render a NeRF? Let's go back to like the cloud analogy. And the way that you render it is by marching rays through this cloud. And you ask the network at each point. So you have your synthetic camera, and in your synthetic camera, you have synthetic pixels. And through each pixel, you shoot a ray out into the scene. And as this ray marches deeper and deeper into the scene, you sample points. And you ask the network, what's the color at this point? What's the color at this point? And what's the color at this point? And it gives you back all these colors, and then you add them up along the ray, and that becomes a pixel. And so our cameras actually don't need to be physically realistic at all. In this one, the camera is on an invertible spherical surface. So you can see the camera rays pointing in orange, and they're a little more sparse than they should be. But as they close over, like each pixel, you're looking at a ray that's pointing like at the center, or now it's curving backwards at the. So I just find this stuff really fun. And if if there's some clever stuff you can do with the fact of ray tracing that's more difficult to do with traditional meshes. And so here what's going on is you've got this bounding box, and you're telling the rays every time a ray leaves the bounding box, pretend it's a infinitely repeating universe, and let's go back to the beginning of the bounding box. And so you're sampling the same image, the same scene over and over again, and you're sort of compositing all these. How do I play this again? There we go. You're just sampling the same scene. And this is very computationally efficient, both memory-wise and speed. Whereas the same thing, like I think this is about 10,000 copies of this choral, but it's really not a whole ton slower than just one copy. And so that's what I'm looking forward to exploring more of, is leveraging the unique features of NeRFs to just make things that make me happy.
I think an important part of this aspect is talking about the differences of NeRFs to photogrammetry. I think a lot of people have experience with photogrammetry, and I can it's a good launching point. So photogrammetry, you could take a series of photos of an object, and then after solving the camera locations, you can give it to a piece of software like Metashape or Reality Capture, and then it'll take anywhere between half an hour to 8 hours or longer to solve that into a piece of geometry with textures, which is pretty amazing. It's been great for the VFX industry for 10, 15 years now. It's used in most visual effects films. If if it's got a CG shot in it, you're likely have touched a photogrammetric model at some point. Now, to compare that, I think NeRFs are very similar in that way. They wind up using the same data set. It's a series of photos. You need to locate where those cameras were when you took the photo. So you can use photogrammetry software like Metashape or Reality Capture to locate those cameras. So you're basically taking the same data set you're doing with photogrammetry, and you can now export a new camera set that is going straight to NeRF. So they are identical photo sets. You don't need as many photos as you might need on photogrammetry side. So whereas 500, 1,000 photos might be okay for photogrammetry, that is going to be too many to be able to possibly use on a NeRF. There's caveats there. I'm going to give some other examples. Unfortunately, I want to talk about it with images, but we got to work that out. So once you export those cameras out and go into a NeRF, you're now got a photo set that you can use. And the strengths over photogrammetry, like I said before, are going to be that they represent photographically, like they appear photographic, even though your highlights and reflections and transparency won't appear correctly on a photogrammetric model. NeRFs, they'll still look natural.
I like to think of it as photogrammetry tells you what something is, and NeRFs tell you what something looks like. Where photogrammetry gives you 3D models that can be insanely detailed and accurate with textures and, basically very sort of objective. It's data, right? Photogrammetry is data, NeRF is photography, and that's reductive. But NeRFs are really good at showing you how something looked from every angle and under those lighting conditions, and then terrible at everything that photogrammetry is great at. They're inaccurate in terms of it's made up, right? It's a big optical illusion, a NeRF, whereas photogrammetry is like data.
So keying off that, I actually like it when people fight, and I want to get Alex's opinion here. And when we were in the green room talking about this, we were bordering on it is heresy. This is heresy. We will not deal with these polygons only on meshes. So I'd like to hear a little bit more about Alex's perspective on this.
Okay, so you're not going to get much drama here, but I'll try. No, these are great points, and you summed it up really well. I want to speak specifically to how we use photogrammetry. We're 3D.
Who is we?
BlueVishnu, our company. We use photogrammetry to get the human form, and we're interested in understanding and representing the human form. And there are some ambitions that we have about getting anyone access to their own model, and then being able to visualize other versions of themselves or future versions of themselves, and And for me, for us, photogrammetry is the right path for that, for understanding the human form to getting that more accurate. But to showcase some of the weaknesses of photogrammetry, so the other room, I encourage you all to go get 3D scanned and taste the cooking. We get you a model in not a half an hour, but 5 minutes. You have a model, and in another 2 or 3 minutes, it's on your phone. So we do produce quick results, but we are producing a result with just a single texture map, a single albedo. So if you're wearing something reflective, it's not going to show as reflective. So there are a lot of weaknesses. We're actually capturing that and then baking in all of the reflections, and so when you put it into an engine, you're not reflecting in the proper way. The process that we've done completely automated is wonderful. Like 5 minutes to get an asset delivered on your phone is incredible, but it does not. There's so much further that we need to go that NeRFs just kind of solve. Like you can, if you nerfify, what do you call nerfing?
Just nerfing. You nerf it.
If you hang 10 in NeRF, an object that has reflectance, you're going to see that the reflections in the object, and they're just going to look right. If you do that same thing with photogrammetry, then it's not going to look right unless you take it on a path of creating a bunch of textures and PBR, physically based rendering textures. And then the same thing for rigging and animation. There's a lot of work that needs to be done to do that. Currently, if your standards are to get as high, as close to photoreal as possible, then it takes dozens and dozens of artist time to do that. And there's no real automated solution for that. There's some great shortcuts, but there's no real automated solution.
I think it's a really great point that there are strengths to both NeRFs and photogrammetry that they don't perfectly overlap and should be used for those strengths.
They both suck.
Yeah. See, it sucked. We'll get to this. We can get a whole nother presentation on that. But I think where NeRF's strength lies is you're capturing something photographic. You can quickly capture it and quickly represent it. It's not currently easily editable, right? That's maybe a weakness. You can colorize it, you can tint it, but you can't currently relight it. It's such a nascent field that I think there's new papers, like hundreds of papers this year alone. So still early. We haven't figured out what format we're going to call it. I mean, there's .luma, there's .valinga, so hopefully we can settle on a standard like USD, maybe, and just have those others as codecs inside of it, I'm hoping. So from an industry standpoint, I think there's lots of things to talk about, what NeRFs are good for and what they're not, but I'm not saying it's a solution for everything. But where it is super strong is representing photographs really quickly. So whether you're going to do scouting, you want to bring something into a conversation from remote, you can put them in a headset or a tablet or experience where you can talk about, point at the same thing and the same thing that exists in reality. If you're trying to make up an alien planet, NeRFs, no, not so much. So if it's their virtual production is a great example of where I think NeRFs could be used, but only if the set really exists, right? If you're having to go and change it, then Unreal, go through the normal pass, scan something, retopologize it, texture it, pull out all the texture maps, clean it, relight it. That's a lot of work, but if it exists, NeRFs are amazing for being as quick as they are.
I think we're talking about today as well. There's huge asterisks on more so NeRFs than photogrammetry of like, a NeRF is this, photogrammetry is this, and then every statement about NeRF kind of has the asterisks of yet. NeRFs can't do video yet. And there's some good white papers, and Synesthesia showed a great demo, and there was a head NeRF thing that came out like 2 days ago. So there is, the paper that kicked off NeRFs was March 2020. So we're talking about an entire field of computer science and computer vision that is 3 years old, which in our industry, the normal progression is white paper, 3 to 5 years later, alpha implementation in some spaghetti pile of code, and another 2 or 3 years before it's a button in industry standard software, and another couple years before it's on your phone and it's boring. But we're talking about now, NeRFs are on, not a week schedule, but it's like months. It's literally like, yeah, we can't do that. Oh, hang on, never mind. We can do that now. So I do think NeRFs are progressing, and a lot of the sort of like clear black and white between photogrammetry and NeRF is going to get really blurry because there aren't hard limitations necessarily. Like I think polygons and traditional VFX is not painted into a corner, but it is into diminishing returns. We have half a century of computer graphics knowledge, and we're getting into sort of really incremental, like last year we could render 1 trillion polygons, this year we can render 1.1 trillion polygons. Like we're very incremental returns on traditional, and the divide that we're looking at now is implicit versus explicit. Everything in VFX is for the most part explicit. Polygons, points, voxels, textures, pixels, UVs. NeRFs are implicit. It's a neural net that has an understanding of what the thing that is stored in it looked like from every angle, and is really good at guessing what it would look like. Novel view synthesis is what it's called. It's really good at just guessing what it probably looks like from angles that were not fed into it. But it's not a point cloud. It's not a 3D mesh. It's not something you can edit. It's not something you can, like grab a point and move it. There are no points. It's literally the neural net just knows what it looks like and is really good at guessing what it will look like from other angles. So that's the divide that we're on, really. It's not really pros and cons of NeRF versus photogrammetry. It's the future of implicit descriptions of the world versus explicit acquisitions of the world. And I don't think that either will die, but they're like, NeRF is the worst photogrammetry tool on the planet. It'll give you the worst meshes with the worst textures. It's terrible. Photogrammetry can't do anything that NeRF can do in terms of reflections and transparencies and everything. So they are kind of diverging. I don't think they're going to replace each other, but they're on different paths. And one path I think is kind of not reaching the end of the road, but it's definitely diminishing returns. And one is a frickin' baby. Like,
It's interesting because speaking of visual effects and triggering my visual effects post-traumatic stress disorder from 20 years in that industry, ultimately the thing is that I saw when I was still at Amazon AWS and Amazon Studios, we met a company that was using NeRFs in a really interesting way, and we were talking in the green room regarding the completion bond companies. And one of the things that they had actually wanted to use NeRFs for over photogrammetry was to do basically when you have a physical set and you don't know if you're going to get picked up for the next season, they do what's known as a fold and hold, right? So they fold the set and they put it into storage, right? They were essentially using NeRFs for sort of digital fold and hold, so that ultimately if you would go then back to maybe and this was also applicable to reshoots, right, and things like that. So if you needed to go back to a set that had been essentially taken down, you could use the NeRFs very quickly on essentially a virtual production stage in order to bring that set back to life. And that was actually mandated by the completion bond company, right? So basically so that you wouldn't have to hit the bond. And I'm wondering if you guys might want to talk about, where do you see maybe NeRFs going in visual effects and that sort of thing. So, Mr. Schugardt, are you okay? Are you well, Mr. Schugardt?
Yes, doing well. Visual effects, if like straight up, what can we use NeRFs in visual effects? So you can capture a static background and then represent a new camera inside of that area. Perfect CG camera for a smooth move, like through that environment, or a move that's impossible, like going through a keyhole or spinning around at impossible vomit-inducing speeds. So there's plenty of applications, and there's been a few uses of that already in the industry. So there was a McDonald's commercial that travels through a Happy Meal that they've shown. So, and I think a few people have jumped on that. But yeah, I think for visual effects that there's a few use cases I think that people would be excited about.
The capture, the processing, and the rendering, while they're connected, are actually very separate problems being solved in parallel by different groups. And if you take enough photographs of something, that like capture's not going to see massive leaps, right? It's a camera. It'll get higher resolution, higher bit depth. We'll get better at solving the poses. Let's talk about that for 1 second. So what a NeRF is, literally, is a folder of photographs and a single text file, a JSON file, that just has in it the position, which is the position and rotation are called extrinsics, and the field of view, the focal length, and the distortion, the intrinsics. The intrinsics and extrinsics of a camera are called the pose. It's literally just a text file that says photo 1 was here, photo 2 was here, photo 3 was here. That's it. That's the entirety of a NeRF. You feed that into a neural net, and it goes, okay, I see where these cameras are, and like James was saying, it kind of figures out the colors and opacities and densities of everything. So capture is not going to see some astronomical overnight, or, you know, like, yes, there will be big multispectral imaging, high dynamic range imaging, all kinds of good things are going to happen. But a photo set that you take today of a set is kind of evergreen to a degree. So the processing, that's the 3-year-old, you know, like that's where all the innovation's really happening right now. You can reprocess that photo set over and over and over using zip NeRF and MIP NeRF and turbo NeRF and INGP and Valinga. It's evergreen on the capture side to a certain degree, but you can just basically keep reprocessing and getting better results. And then rendering, right now, there's a few tools, turbo. James is really humble, by the way. This man has single-handedly written a NeRF implementation in Blender as a plugin. This guy's
Yes.
Let's hear a little bit more.
literally, there's like massive companies raising tens of millions of dollars, if not hundreds of millions of dollars. And freaking James is just like ChatGPT and Blender, and it's astounding what he's doing.
Well,
But
let's hear from him on that.
yeah,
Yeah, so I mean, we were talking about like NeRF and VFX right now, and I think one of the major hurdles is there just aren't a lot of tools. Like you can use Luma, you can use their Unreal Engine plugin, and you can manipulate static scenes. And you can use Turbo NeRF, and you can also manipulate static scenes at lower quality. And so if you're okay with this stylized, like cloudy, sort of ethereal effect that you see in NeRFs, then I would say they are usable in VFX today. And it's a very rare thing to do it, so it might lead to something special before they like blow up. And like you said, it's on your phone, and now doesn't matter anymore. Everyone can do it. And there's also a lot of potential for, like, we don't have video NeRFs right now, but if we have camera arrays that can capture 30 frames per second video, then you can just train each frame as a different NeRF, and you can swap them out and sort of come up with this synthetic video. So there's a lot of avenues to approach this at, and yeah, it's just an issue of tooling right now. There's just not like an After Effects plugin. There's a Blender plugin. It's an Unreal plugin.
yet.
Exactly.
We're back.
Oh, actually, no, one just came out.
Right away.
All right, we're
Back on the.
we're back on the track. We got
Okay, cool.
the technical thing.
So we're going to turn it over to Jason.
Can you all see it, or do we
Yeah.
do sit in the
So
front row?
it's all fine.
Okay.
I just wanted to touch. This is really touching back to the point that how photogrammetry and NeRFs is so similar. You know, if you're into capturing it, there's a couple different ways. We can do a DSLR camera with the highest quality still images. You could do a faux camera. This is the camera that you have is the best camera sometimes. And really, often the best way to do it is actually capture a video and then pull a frame with script. You can pull a frame out of every nth frame, 10th, 30th frame to then train a NeRF on. The hardest part right now at the moment is getting the locations of where those cameras are in space. So this is something where videos are helpful. You can solve the entire path, use more data in the video to understand where the camera is, and then there's not a really good path here, but you have to script this. Extracting the camera out and then drop that into an NGP, and this is where a lot of the NeRFs you're seeing are being done. I'm most excited about the middle option here is 360 cameras. So really quickly, you can walk down an alley. Let's say, I'll give you an example in just a moment. The process you train, this Grade to Turn has done a great pipeline by the way. If you're Grade to Turn on Twitter, you capture the camera in 360, you extract the center, track that view, and then inside of the NGP file, you can denote that it's a spherical camera. So it is now training in that location, every single direction for every point that you track, which is amazing. So you're no longer having to take thousands or hundreds of photos with a DSLR or a video camera and swinging around. You're doing it faster with a 360 camera.
Okay, now we are gonna fight.
Yeah.
So here's my anti-360 alternate view.
Yep.
Which is a camera that can, an array that can see in every direction, has more parallax, and you can basically train on the fisheye images without undistorting them. A 360 panorama is at least 2, if not 3, filter hits to convert the fisheyes to equirectangular and to stitch them and possibly to warp them as a third step to fix any parallax errors. So if you train a NeRF on that, your input images have been filter hit 3 times before you train. So your NeRF will be soft. So I think there's a middle ground, which is solve the 360, use the 360 to solve, but then train on the source fisheyes.
Yes, I agree with you there. There is
Good fight.
There is a way. Yeah, we fought to agree.
Would you use instant 360 raw files to train and just not stitch the image together at all?
That's my hill. I'll die on it.
Yep. I think I do agree from the quality point. I also say that at a 6K camera is not that great, right? So if you're looking for high quality images, the 360 Insta is not going to give you the sharpest images ever. And my point is maybe that's not the point. Is the speed of capture in that particular example. If you want the highest quality, you got to shoot the photos with a decent DSLR, and they have to be sharp focus. They have to be very shallow depth of field. These are deep. Yeah.
Deep depth.
Oh, sorry. Yeah, deep depth of field. So no, you want everything sharp, pin sharp. So just giving you a quick example of what some of the good stats that you'd want to use for shooting photogrammetry, and these are also great for shooting NeRFs. And you want to make sure in photogrammetry you don't have shadows, you don't have things that you want to see. NeRFs kind of, in some ways, ignore those or will include them.
They get included from the angle in which
Yeah.
they were seen, and then they're invisible from the angles they were not.
Yeah.
And you can use that for really cool artistic effect. If the lighting changes or a shadow moves across something or somebody moves, they technically exist. So if a person walks like this through a NeRF as you're capturing it, they technically exist in every single position simultaneously in the NeRF, but they're the color of whatever photo was taken. So while they're here, they're the color of the wall when viewed from an angle in which they were here. It's a little bit of a mind bend, but
Yeah.
it's basically, it doesn't make people go away. It paints them the color of the background. They're still there. They're in 3D space. They're a big, long blur that just changes color based on viewing angle.
Talking about a mind blend, you actually had a really cool project that was of a space and time through all space and time, where you shot a rigged camera traveling across at multiple times with candles burning, clocks going.
It was 15 photos. It was a motion control slider. So it was 15 photos taken 80 times over the span of about 2 hours. So every 15 photos is one NeRF. And that means every sort of frame of the NeRF. I had 80 NeRFs, basically. So every NeRF is sort of as close to one moment in time as possible. It's, it took like 30 seconds for it
So-
to traverse.
Like, can you talk to us about interdimensional NeRFs? Is that the next step beyond?
That's next.
Yeah.
No, the thing I'm working on now is using a camera array. So I shot it in June, and I'm trying to process it now. Was shooting a camera array. So it's like photogrammetry, where you're taking a snap, but all of the cameras were set to 2-second exposures, and we had strobes firing off. If you've ever seen shutter drag photography, it's where there's a blur, but then there's a sharp part as well. So what you do is you do a 2-second photo, kind of in the dark to a certain degree, with maybe like an edge light or something, and then the thing I did was a dancer. So you see her motion, and then we would fire a strobe either at the beginning, the middle, or the end of a motion, and we did both. And so she basically is, hitting a pose, but then there's a blur either leading into that or out of that, and then we're feeding that into NeRF, and getting essentially a NeRF that is not sharp, is not one instant in time, is not static. So it's motion. And the array we used has a 30 camera bullet time array. So we also did cascades where it was a 6-second cascade from the first, each camera is taking a 2-second exposure, but it's going across in a cascade. Based on the viewing angle, she basically exists in all of those positions, but based on the rendering camera as you're moving across, she moves. But she doesn't move, it's just that her color is changing. Her color is changing from the black background to her body foreground based on the viewing angle. So we actually can do a NeRF that is animated by the viewing camera, but is not actually animated.
Yeah, I've seen this work also for drone shots where you capture, you're obviously moving through space and time. But so when you're representing, say, an ocean scene, depending on where you are in that camera, you're going to see the waves move. So if you recreate the drone move, you're going to see the waves crash as they were, or sped up or not. So it winds up having a really interesting effect. And I think Andy's really explored an interesting slice of this technology in ways that I haven't seen done anywhere else.
Well, speaking of
It's super dumb though. Like no, like it's really dumb. It's like party tricks. It's like NeRF party tricks. It's not. I'm not a computer scientist. I'm a power user. Like I'm just using the technology. I can barely code, so I'm not like inventing technology. I'm just working on technique using the technology, like ways to do fun stuff with it.
But this is like there's so many of these, maybe you'd call them low-hanging fruits. Like there's just NeRFs are so niche right now that they're all free.
Yeah.
I mean, that's all I'm doing with like the compositing stuff. It's like, yeah, this is obvious.
So I have a question for you guys. We were talking about projects, and you guys were talking about a project that you worked on, the one that sort of flew off the rails. And do you want to talk a little bit about that?
Sure. Actually, this is kind of fun because this is a little bit of a case study of strengths of both photogrammetry and NeRF, and this is a project. So one of the things that we do is what we're doing out there, which you can hop in the scanner, get scanned, and then we'll render a video of you. And we had a client call, or a potential client call, about a project they wanted, and they wanted something very similar, except they wanted to augment the person, put in a different appendage onto their head. And that's something that is that's something that would require traditionally, like we would need to model that. And so if we wanted to do a few hundred of people at an event, we would need to hire literally an army of modelers to make that happen. So I called Andy and said, "Hey, Andy, you're a power user that can make crazy things happen. What would you do?"
So I said, have you heard of our Lord and Savior, Instruct NeRF to NeRF, which is Instruct NeRF to NeRF is it's built in right now to NeRF Studio, which is one of the tools for training and rendering them. And what it does, there's a generative AI called Instruct Pix to Pix, which basically you feed a 2D image in, and then you use text prompts to describe what you want to change. So you have a picture of a guy, you say a guy with a hat, and it will generate a hat. But that technology just generates each image individual. Oh, you've got it, rad. There it is. So the NeRF Studio folks,
See and say.
almost like we planned it. The Instruct NeRF to NeRF basically takes all of the input images, the 50, 100, 200 photos, and runs on each of them that prompt and adds a mustache, turns it into bronze, whatever, and then trains the NeRF. And there's a thing that James kind of mentioned that's kind of at the heart of it all, a loss function. And a loss function basically just says, generate something, and this is what I want you to have generated. The loss function is just a number that tells you how far apart they are. And you keep going thousands of iterations until that number gets as small as possible into diminishing returns. And then your neural net is now producing something as close as possible to the desired outcome. So what they do in Instruct NeRF to NeRF is modify the input photos, make a NeRF, compare the NeRF to the input photos as rendered from those same angles, and kick it back to Instruct Pix to Pix to run again over and over and over and over and over and over and over again in a loop until the input images have been text edited in a consistent way as close as possible, and it produces basically this, which is, it's fuzzy, it's blurry, it's a NeRF.
And just to be clear, it's not real time. So what you're seeing here is video magic.
Oh yeah,
editorial.
it's slow, and there's probably a stack of GPUs behind this demo.
So we would start off with a photogrammetry asset, traditional photogrammetry asset, and then use that as a training set for NeRF. So we can, let's say, pop it into Blender and then just render out as many frames as we think we need to get a good NeRF out of that, train a NeRF out of that, and then run it through instruct NeRF to NeRF. The interesting thing here is, so there's no real great solution for doing what we want to do traditionally. This is, I think you called it a crazy NeRF trapeze act that we would have to do to pull this off, including like dozens of servers on location. It just would have been a massive production, but it would have been viable to do in a short period of time. And the thing about this is the AI is not art directable. So if we wanted to create an augmentation that had some interpretation, and we lean into that, then that's the answer. But to actually create, in this case, the augmentation needed to be very specific. So there's really no way to do that. Well, you can influence the AI. You can't tell it what to do.
Using generative AI, especially the 2D image AI, at some point pretty early on, like everyone that's talking about prompt engineering, I think is like the part of my brain that generative AI kind of triggers is, I've been a supervisor, I've been a lead, a supervisor, a creative director, a director. It's directing. It is using your voice, your words, sketches, some kind of facsimile to work with somebody else to get to a point. AI is really dumb. It's actually ML. There is no intelligence. It's just learned. And it's really hard to get what you want out of any of the generative AI because it's not smart, so it can't understand you. And it's a relationship. It's a lot more like directing and just being like, no, not what I was thinking, but we'll go with it. That's cool. It's interesting.
That
Okay,
brings up
cool.
an interesting point. We're at probably a little bit more than halfway before we mentioned the elephant or Satan in the room that is AI. And I wanted to hear from you about kind of where you see, and then from everybody else, where do you see AI fitting into the NeRF process?
From me?
Yeah. From
Oh man. Well, I mean,
quiet.
yeah, I want to make a distinction here because I personally don't believe that NeRF in its pure form is AI. It uses the neural network as an optimizer for this five-dimensional cloud, but it's not like intelligent. Like the human part of this has defined the radiance field and differentiable rendering, what that means. So you give the neural network all of these tools and you just say optimize this loss function, this number, minimize it so that the images look as similar to the ground truth as possible. I think there's a lot of fascinating stuff being done with NeRFs that, like in AI, to answer your question about like the instruct NeRF to NeRF stuff, like that. I personally, I don't know. It's probably taking somebody's job away, honestly, though. But it's like how difficult would that be to like go into each image and draw a mustache on the person? And I suppose you could just put a mustache on. Okay, yeah, it's taking people's jobs.
Where I think it's interesting, I mean, if you ask where in the process, I see this in two places. The holy grail for me on photogrammetry is being able to, for an algorithm to be able to understand, like, oh, when I go shoot this backyard and there's a bit of concrete, that I don't have to go in and shoot like down to the pore level of what concrete is. It has an understanding of what concrete is. So whenever it recognizes concrete, it adds detail in there that is not there. And that could be done in the photographs, right, potentially. But I think more exciting would be done at the end where and this is already happening with face scans, where you shoot you have like old footage and you want to generate new detail based on thousands and thousands of other faces you trained upon with high detail, you can infer that detail. So you get high res, concrete or high res wood texture that is as a second layer or an improvement layer on top of the NeRF after the render.
Alec, well, let's let Alex go for tell us what you think AI fits in, even the photogrammetry process and all of that. Where do you see AI fitting in?
Sure. Well, I already talked about our pipeline and where we are at now, and some of the problems of not being able to. If you want to render it accurately, you need to have artists and technicians spend dozens of hours, which just simply doesn't scale. So I think that's absolutely an application where I see can certainly help photogrammetry. So being able to auto rig that's a problem that AI can help with, and
And you're specifically talking about like the motion rig that underlies the
oh yeah, sure. So like a physical body rig. So
Yeah.
like in
so like an inverse kinematic rig or
exactly.
Okay.
So if you want to animate a form, the uh, instead of talking too much about where we're going, I can tell you where we've been and how we've applied very simply. So the most of you guys are probably familiar with Street Fighter. Show of hands. Yes. Okay. So Street Fighter's got a Hadouken pose, and they just released Street Fighter 6 about a month and a half ago or so, and we brought our scanner to this party. They invited influencers, and everyone hopped in and got into a Hadouken pose. I think you can actually do that with this scanner too, although Ty might kill me for suggesting that, but you might be able to try that here. But we had optimized our cameras so that you could put your hands out and scanned everybody and then put you into this video. We call them omnigrams, but it's basically we rendered out a video with you holding this big fireball, and the fireball was shooting out in the direction of an enemy, and you were crushing an enemy. Super cool, and we got that rendered and delivered in 10 minutes, and that was awesome. But we did have a problem because people are different sizes. So we didn't know where your hand was going to be. We had to figure out where your hands were going to be, and then we also needed to figure out the vector and the velocity of, or so the vector of where it was going to be pointing, and because it was exploding into an enemy. So all of that needed to be figured out. There's a couple of different approaches. One is just using heuristics, which are kind of dumb and really, meaning like we know that your hand is probably going to be the furthest away, or the furthest piece of geometry on the y-axis, and then we can start to estimate where to place it. But heuristics are really fallible. You can, like, if somebody's foot is a little further away, then suddenly the fireball's in somebody's foot. And it didn't work. So what we wound up using is pose estimation to detect where all parts of your body are, but the most significant was where your hand was. So we could detect where your hand was and then place the fireball in that and then send it to where it wants to be. Now, that's a very trivial application, but it was one of the first ways that we introduced that into the pipeline, and that is at its heart how we begin to start understanding the body, and how we start to understand where the rig will be placed, and how we start understanding shape estimation, and how to change and view and understand your body's shape. So it's the groundworks that are being laid.
So I agree with James. I like to really kind of hammer home that, like, there's almost no AI in the world right now. There's a lot of ML, there's a lot of machine learning, but it's calling it artificial intelligence. You think intelligence, you think something over there, you think it's going to steal my job, it's gonna put whatever. So I always refer to NeRFs as like the safest of the generative AI, because A, they're clearly not intelligent, and B, they're barely generative, right? Like a NeRF on itself, it is generating 2D images, and you can generate meshes and normals and depth maps and whatever, but it's not what we think of when we say, we think Midjourney is generative AI, but a NeRF is kind of just a 3D scan so far. So if you apply other AI technology, other ML technology to NeRF, you can kind of go from this very simple little thing that just kind of like renders 2D novel views of its inputs. You can do things like instruct NeRF to NeRF, but you can also do things like there's segmentation tools now. They can basically go, that's a body, right? Or not, that's a body. This is a shape, right? So segmentation is just, this is a shape, here it is. Then we can add semantic tagging. This is a body, this is a head, this is an arm. So if you have, say, oh, I don't know, millions of NeRFs because you're Luma AI, and your EULA says, we get to use your data however we want, then you can train a generalized NeRF model, a generative NeRF model. It's one that has semantic understanding, where you can do text to NeRF, where you can say, give me a marble table. Or you can edit NeRFs, say, find the table in this scene and make it brass. That is the asterisk on NeRFs, is that right now they're very simple, but they're gonna get really complicated. I think one of you just almost kind of mentioned, or you sort of mentioned inverse rendering or differentiable rendering or neural rendering, a lot of different terms. It's very much white paper right now, but basically it is a different neural net, a different architecture that you basically give it a 2D image, and it iteratively, using the loss function, basically tries to guess what 3D scene would make that image, what the geometry is, what the textures are, what the UVs are, what the materials are, where the lights are, what color they are, what kind of intensity they have. And it just iterates. It just makes a 3D scene, renders it, compares it to the input, and if the loss function is too big, it tries again. And if on the next iteration the number goes up, it knows it's headed down a bad path, and it chooses a different path. Just rolling dice until it basically creates a 3D scene that can, after thousands or tens of thousands of iterations, be rendered in standard 3D software and generate that output. So that's going from a photo or a render into a 3D scene. But what if you start with photos, make a NeRF, and feed that in? Because a NeRF has a good understanding of the color and the opacity and the shape. So that differentiable renderer, that neural renderer, is 80% of the way there already at iteration 1. It doesn't have to guess what the geometry of the scene is or the color of the scene is. Now it's into those sort of, it's either gonna get to a good result faster or it will get to a better result. So now we've got two AIs marching through the VFX pipeline at each other and complementing each other and basically handing off. And then you start adding GANs and all kinds of, and generative, editing and everything.
Also, synthetic data is another, good use where with a very sparse data set, you can generate more data that you can then do all the applications that Andy's mentioning here. Really amps up the possibilities.
Well, it dovetails nicely into the next question that I have. And that is, where do you guys see, like, what technologies do you see sort of over the horizon? And I know you don't want to answer this question, but that's fine. I'm going to make you answer it anyway. What do you see kind of over the horizon that's exciting to you that you think, like, beyond NeRFs or, meta NeRFs or whatever you...
So, NVIDIA is involved in lots of things that are dealing with the future. I think we have a lot of, robotics and autonomous vehicles are one of those things. So there's programs like Google's Waymo and Wave in London. They are capturing, Waymo is capturing block NeRFs. So an entire scan of San Francisco, millions of images, huge data sets, and being able to then generate novel views of moving down the streets. Why would you want to do that? Well, one of the challenges of making a car drive safely down the street is you just can't throw a computer in the car and just let it go. You have to you're gonna train that in a computer, right? You're gonna let it move down that, simulate what that is. If you just generate a CG image that doesn't look real and you train your vision AI off of something that's not photoreal, when it gets out in the real world, it won't recognize anything that it sees. So this is where NeRFs allow you to synthesize the world that you know is photographic and then generate as many experiences for that robot to travel down the road as you want. And so they have scenes where you can extract the cars and then you generate synthetic cars. So these would be polygons in the normal way, but they are reflecting the environment, which is exactly what cars do. So they fit into the scene perfectly. And now you're synthesizing every possible action or arrangement in that NeRF. And now you can extract that and dot the lines out. Say if you want to have a robot that makes tea in your house, how do you do that? You're not going to have a guy wearing a camera going through thousands of people's homes, finding the tea in the cupboards. You're going to synthesize that. You can't possibly have that data all captured on your cameras. You're going to capture a single NeRF, and then through all of these iterations, generate data that you can train AI to navigate these worlds.
I'm just looking forward to the artistic uses of NeRFs and the VFX uses and video NeRFs becoming more feasible to do, and just really exploring leveraging the volumetric approaches of NeRFs.
I'm curious, are you guys like going out on eBay and trying to find bullet time rigs for 5 cents on the dollar?
Yes.
I thought so. And how about you, Mr.
Really just interested in faster and more automated ways of doing what we need to do, like what takes a long time to do now. So that's what I'm most excited about. That's not an exciting answer. I'm sorry. Flying cars?
Well,
Flying cars.
yeah, there you
Flying
go.
cars.
That's my answer.
Flying cars are good. Well, it's essentially, but it's a good question though, because ultimately, I'm going to say this without having Mr. Schugardt stab me to death. But ultimately, the thing is that we are entering an interesting time as far as like resource allocation. I'm trying to put this as diplomatically as I possibly can. We might not have enough GPUs on the planet.
Thank you, Andy. No, that's a problem for everyone.
It certainly is, yeah. And so it's worth thinking about. These are computationally, expensive no matter how you look at it. And ultimately that's an issue. And I didn't mean to skip you.
No, not at all. I was going to just say, thank God crypto crashed.
Yes, totally. Sam Bankman-Fried may be the hero of this story
Yeah.
after all.
Saved AI. I mentioned a whole bunch of technologies that I'm excited about. The one I didn't mention is it is just a math problem. And it's just literally like a resource allocation problem.
Sexy.
I want 32-bit float HDR NeRFs. I want a NeRF
Second that.
that is the full radiance of the scene from the pure black to the pure white, because that will create the best real-time lighting, best VFX lighting, best looking image. It's not about relighting it, but it is about re-exposing it. Like an LED wall, this wall cannot display the full luminance value of a 32-bit floating.
So you want an
And
HDR
there's-
NeRF?
And by the
Yes.
way, there's nothing stopping you right now because Instant NGP already supports float and
Does it?
yeah, dynamic range.
16 or 32?
At least 16. So we can do.
Well,
we-
half full stage. So.
Well,
That's MDR. That's mid dynamic range.
we have about 10 minutes left, so I wanted to make sure that we got the questions from the audience. So
Yeah, let's do it.
let's rock and roll that. Is there anybody? I see.
Hello. I wonder if there's any benefit, either computationally or resolution-wise, to feeding the system native stereo images. Have you experimented with that at all?
It doesn't. So if you have a surface that has a lot of delta, a lot of change, like a glass table that as you're moving, like, sub-inch, the reflections are moving over it, you can't have enough photos of that surface from enough angles. So yes, in that regard, having more than one camera capturing is good, but it doesn't do any sort of triangulation. There's no correspondence points. There's no photogrammetric reconstruction in a NeRF. So having a stereo rig can help photogrammetry. It helps capture a NeRF faster because you've got more than one camera. But it's actually, in most cases, better to have a rig in which the cameras are more than sort of a normal IPD stereo apart. Like a good capture array would be like a big cross where they're like 2 feet apart with nice high resolution sensors with glass that's pretty wide angle, but not so wide angle that you're dealing with fisheye distortion, or not distortions, but chromatic aberrations and vignetting and things that are, you know, unusable parts of the lens. That's what you want more so than any sort of like calibrated stereo array.
And I'll throw a little asterisk in there too, and this is something that Andy's explored. We can make better NeRFs, especially this is in some ways with depth, right? If we know the depth of a scene, whether you've captured that with a Azure Connect camera or whether you've captured that with LiDAR, you know, these are ways that you can inform, like, I know the surface is there. These are where the points are. That the caveat is sometimes things you do want fluffy and fuzzy will then won't look as well, and you'll fall back into the photogrammetry side. So hair or things that are wispy, it will. There's no way to currently no way of balancing those two modes out.
Okay, another question? I love that I sort of understand everything you guys are saying.
Gosh. Sorry. Question regarding AI and creating NeRFs and the talk about you would need to make a physical set first to capture a NeRF. Has anybody played with making their own model with their own assets of visuals and spitting out, you know, AI generated images and creating NeRFs from that?
You can do 3 things. You can take a bunch of photos of a real thing.
Yeah.
You can render CG. You know, like you just a bunch of cameras in your CG scene. There's plugins in Blender that do it automatically, or you can edit the input images to insert CG, or you can paint people out if there's moving objects. You can add CG. I did a really dumb thing with my time lapse thing, which was literally I was like, I have 15 camera poses. Could I just render the Blender monkey head and then just slap it over the photos and then feed that back into the NeRF? And now I have a NeRF that is a photographic scene with a CG Blender head floating in it.
Yeah.
And the more integration you do, the more realistic that'll be.
So the very first NeRFs that were generated, and I'm sure everybody's seen this picture a million times, is the dozer, right? That's all synthetic data, right? So
It's just CG.
yeah. So that dozer does not exist in real life. I'm sure somebody's made it, but that, for the example for NeRFs, that's all synthetic.
Up here, I think, in the front.
I'm coming.
Sorry.
These are real shoes, not NeRFs.
You guys talked about sort of the divergence of photogrammetry and NeRFs, and I was kind of curious about either with AI or with other methods to utilize the reflections and the data that you have from the NeRFs to composite and build onto the photogrammetry so that you have better reflections or different angles that you guys can maybe have a virtual camera after the fact that is maybe reprojecting the luma fields onto the photogrammetry so that you do get those reflections, or you maybe cake them into different layers of the photogrammetry so that after the fact you have that information that you can kind of pull and you know, utilize. I'm just curious if
That's how one of the real-time rendering tools works, isn't it?
So I know there's a ton of research on this, and there are ways that there was one paper that came out about using NeRFs just for like surface reconstruction, so things like hair or like carpet fuzz are very good. There's also just telling the network, instructing the network to optimize the actual what are they called, the BRDF, the surface. Like you in a traditional 3D mesh, you have like you know your UV mapping or your textures or some albedo or some specular reflections, and so the neural network can actually optimize that. So if you wanted to get like an AI driven traditional result, I know there's active research on this.
There is neural materials for sure.
Yeah,
Like
that was NVIDIA, wasn't it?
Yes.
Yeah.
There you go.
Good plug. But that is the inverse. That is neural rendering, is hopefully that you get to there where you get the shader. So you get a piece of 3D geometry and the shader that will match what the NeRF saw that real object looking like. So yeah, It's in the lab. It's not. It's in the white paper in the lab. It's not even like in our hands. They basically work from opposite ends and meet in the middle and create a like fantastic 3D scene that you can then rig, animate, edit.
So much like the Academy Awards, the band is playing us off right now. So I want to thank all the panelists for the great job they did. So well done. And I'm sure these guys will be around, walking around for you to question them and beat them up about things. So off you go.
Let's have another big hand for our Johnny Cashes. Thank you so much, guys. So just breaking for lunch now. We'll be back in an hour for a session on mocap with disguise and